Hi there, this is not a chair modeling tutorial. This is how you can model using non-destructive modeling techniques using shrink wrap modifier, geometry nodes, and a mix of modifiers to achieve reusable parametric modeling in Blender. So let's get started. So we'll start with a cube, but this one is not the default cube. I'm using an extension called ND Primitives, which has many nice parametric primitives. You can control the cube dimensions anytime. You can also set the origin at bottom. I'll be using this cube as a visual guide for the chair dimensions, so I don't want it to be rendered. I'll rename this collection to guides and disable the whole collection in render. I also like to show the option to disable selection. Lastly, in object properties, I'll set the viewport display to wire and rename it to guide. Now let's bring the reference image, drag and drop to a new image editor. These are some combined images of the chair, and here are the dimensions. So let's start with the base, which is 46 by 46 centimeters, and its height is 45 centimeters. Let's duplicate and set the height to 29. For the total height, duplicate and set it to 79. I'll change its width to 42. To set the back height, let's duplicate this one and move it up here. At 79 centimeters, rotate it on Y and 80 degrees, then set its height to 36. Then to create a guide for the seat, duplicate this cube. Move it 45 units on the Z-axis. We'll set the height to 0 and set both the width and length to 41. Dimensions are done. Now let's create a new collection for the chair. Snap the 3D cursor to selection, Shift A, add a grid, set the X and Y to 41, and add some loops. Then add subdivision surface modifier, add solidify, set thickness to 2, and the offset to 0 so the origin would be centered. Now let's add another subdivision modifier. We can duplicate this one, move it down here, set it to 2 levels. This first one should be 1 in render. Okay, the seat surface is not smooth, so we add shade auto smooth, but it's not working because the grid is created with geometry nodes. So we need to edit the grid in geometry nodes. Select the grid modifier and we add set shade smooth, but we don't want to change this grid node because it's the default one. It's called every time you create a new ND grid. So we press here to make a copy of the node. As you see, the name has changed. And now right before the group output, we add set shade smooth, and now it's smooth as we need it to be. Now we need a sharp edge here. So let's add a bevel before the subdivision. We can pin the subdivision last. Then add a bevel modifier. It will create new edges which will act as support loops. And then to get rid of this sharp corner, we can increase the limit angle like so. Now we'll temporarily disable the subdivision to better see the edges. And then adjust the bevel amount and re-enable the subdivision. Now let's deform our model by adding a bend modifier. Pick the Z-axis, then to make it bend upward, we'll use an empty as the origin object. Add an empty arrow, it's tiny, so let's resize it. Okay, that's fine. Now back to the bend modifier. We pick the empty and rotate it 90 degrees on the X-axis. The bend is too much, so let's decrease it. I think we need to reduce the thickness a little bit, and it's not a problem thanks to non-destructive modeling. We can easily modify the solidify thickness anytime. We can also decrease the bevel amount to make the edges sharper. I know that you can get the same result with box modeling, but later you'll see that we can easily reuse this same object to create other parts of the chair. Now we'll add one more modifier, because this part is not a uniform square. So we'll add a new simple deform modifier. Choose taper. Pick the Y-axis and adjust the factor to our liking. Now let's model the front leg. So let's snap the 3D cursor. Shift S, cursor to world origin. Then add a cylinder from the ND primitives. Set origin at bottom. Adjust the radius. I'll eyeball it for now. And set the height to 45. Let's reposition it. G, Shift Z to constrain the movement on the X and Y only. Refine the position from the top view. Now there is a slight tilt in the leg, from the side and front too. Usually, to get this shape without rotating the top and bottom of the cylinder, you would use edit mode and skew it, but we'll do that using geometry nodes. But first, let's make the cylinder edges smooth. So let's add a subdivision surface modifier. Hover on the object and Ctrl+2. Of course, we don't want that look. To fix that, we'll add more fill segments. We need at least 2 segments. Also increase the height segments. We also need to smooth the shading, but if we add Shade Auto Smooth, it won't have an effect again. So we head to Geometry nodes to fix it. Choose the cylinder modifier. Don't forget to make a copy. And like we did with the grid object, right before the group output, we add Set Shade Smooth node. I think it needs some extra side segments. Now we'll make our own kind of skew modifier. Let me explain the math behind it. Imagine we want to push the top faces to here, and the segments in the middle should gradually shift in the same direction. So we'll use the Z position values of the segments. If we remap these values from 0 to 1, then we use it as a factor to push the X position of each segment. So let's do that in Geometry nodes. First, let's add Set Position node. So if we change the X values, all the vertices will move the same amount. Also, the same applies for the Y direction. In our case, we need to shift the top of the geometry around 3 units in the X and Y. But we won't set it manually. We need to drive this shift by the Z value of the vertices itself. So to control each axis separately, we use Combine XYZ. Now we add a position node. Separate XYZ and connect the Z position to the X component. As you see, we got an effect similar to skew, where the Z position of the vertex is added to its X position. If we check the object dimensions, you can see it's 45 plus the cylinder radius. So now we'll remap the Z values to gain more control over the result. First, we need to get the object height. We'll add Bounding Box node. Here, the max socket has the maximum XYZ values of the geometry dimensions. So we'll separate the values, duplicate this node, connect the max output to the vector input. Now we can add Map Range node. We connect the Bounding Box Z value to the From Max input. What this node does is, it reads the Z value and remaps it to values between 0 and 1. So we'll multiply this 0 to 1 factor using a math node, add multiply and multiply by 3. Now we need to do the same for the Y offset. Duplicate this node, shift Ctrl D to keep the input connection, and connect the output value to the Y input. So now we have separate controls for X and Y, and to control them from the modifier panel, we can connect this value to group input. Click and drag this input socket and release. Search for group input and rename it to X skew. Add one more group input for the Y control and rename it to Y skew. Then we set them both to single value. Now we can set the values from the modifiers panel. It seems that this seating part is not centered. Sure it isn't. So let's fix that. Select the grid, then the empty, and Ctrl+P to parent it. Select the empty and move it on the Y-axis and refine the ESQ values. Lastly, we'll select the leg and add a mirror modifier. We need to mirror it on the world center. So with the 3D cursor at the center, Shift A, add empty, resize and rename it. Now back in the mirror modifier, in the mirror object, we pick the empty. Now let's make the back legs. Duplicate the front leg, move it back. We'll reset the skew for now. Adjust the height, increase the side segments. From the front view, adjust the skew values. Now let's shape it with a bend modifier. Shift A, add empty arrow, resize and rename it. And reposition it where we need the bend to happen. Rotate it so it would be aligned with the leg as close as possible. Back in the leg object, we can pin the mirror last, also pin the subdivision. Then add simple deform. Bend. Pick the empty. Adjust the restriction limits. Until we get the desired shape. Let's parent the leg to the empty, then rotate the empty. Adjust the bend value, rotate the empty again, some back and forth until we set it right. And we can make some refinements too. Now let's make the top rail. We can duplicate the seat object and its parent empty. Select the empty and reposition it. Select the grid. We don't need the taper here, so we'll delete it. Adjust the grid dimensions and set the Y vertices to 2 so we get the rounded sides shape. Adjust the bend value and reposition the parent empty. Now let's add the front stretcher. Create a new cylinder and reduce its radius and reposition it. Then rotate it -90 degrees and adjust its height. Add shrink wrap modifier and set wrap method to project and pick Z-axis. Pick the target object, which is the legs. Increase the limit so only the vertices near the leg would wrap. 1 centimeter is enough. And for the other side, we check negative, then we can add a bevel modifier. Set the amount to 0.2 and add some segments to the bevel. And we may also add a tiny offset to the shrink wrap. Again, shade smooth won't work here, so we add it to the cylinder's geometry nodes. Copy the node and add set shade smooth. Now in the same way, let's make the side stretcher. Let's duplicate this cylinder, rotate it, and reposition it. Adjust the height. This connection doesn't look okay because the cylinder is penetrating the leg, so if we decrease the cylinder depth, we're good again. For the back side, we duplicate the shrink wrap modifier, clear the target object, and pick the back leg. Set the projection direction to positive only, and adjust the limit. And for this side, the projection should be negative only. Lastly, we add mirror, and pick the mirror empty. For the back stretcher, let's duplicate the front one, and reposition it. In shrink wrap, clear the target object and pick the back leg. That's it. I love non-destructive modeling. If you like it too, please hit the like button and subscribe to support the channel. So, to make the front apron, we'll duplicate the seat again. We don't need the bend and we don't need it to be parented too. So Alt-P and clear parent. Then let's reposition it. Adjust the dimensions. And adjust the taper factor. Increase the X vertices. And let's temporarily disable the modifiers. Then add a shrink wrap modifier. Reorder it so it comes right after the grid. Set the method to project. Pick Y, and for the target, pick the seat and increase the limit. And set a small offset. Now let's enable some modifiers. Enable solidify. Bring it above the subdivision. Then enable subdivision. so we have an edge loop here. Then we bring the taper after the subdivision. Let's add another shrink wrap. Select project. Pick X, check positive and negative. Then pick the leg as a target and set the limit to 1. Now let's drag the bevel after the shrink wrap and enable it. Adjust the amount and number of segments. And enable the subdivision. Okay, let's make the side apron. We'll duplicate the front one, rotate it -90 degrees, and position it. Turn off the side's shrink wrap and remove the top one. Turn off the bevel too. We also don't need the taper here. Position the object and adjust the width. Let's turn off these modifiers for now. Adjust the grid segments. And press Ctrl+A to apply the grid modifier. Now let's turn on some modifiers and check the shrink wrap settings. X-axis OK, cylinder OK. Then duplicate the modifier, clear the target, and pick the back leg. Enable the bevel and the subdivision. Now we need to use the edit mode for the first and last time. For clarity, I'll disable wireframe and hide the guides collection. Now I'll scale some edges, so I'll use this edge as the scale center. Press period and choose active element. Shift and Windows select these edges and scale on local y-axis. Then adjust the loops using local x-axis. And for better looking mesh, I'll add cut loops at each side. And adjust the limits. Lastly, add the mirror to the end of the stack. Now let's duplicate the front apron, move it on the y-axis, and set it upright. Now, the main model is done. In this next part, we'll add some screws using geometry nodes. Starting from this leg, we'll add a new geometry nodes modifier. I'll cut this connection for now. To model the screw, we need a curved circle. Radius 1 is OK, and we set the resolution to 16. Duplicate it. Set radius to 0.5 and the resolution to 6. Using Node Wrangler add-on, I'll join them together and connect it to the group output. Now let's extrude this shape. Oops, I forgot to turn them into mesh. I should have added fill curve before the extrude. OK, decrease the extrude offset. To get rid of this web, we should uncheck individual. Then to fill the center hole, duplicate the fill curve node and connect a small curve to it, then join these two nodes. It looks okay, but in fact they are two separate meshes. If we add a subdivision surface modifier, we get this result. To fix it, we add a merge by distance node after the join node. Now it's a single mesh, and we can remove the subdivision as we don't really need it. So to see both the leg and the screw, let's bring the group input node here and join them together. Now the screw is right at the leg origin point. The screw needs to be smaller. So let's control its size with a single value. I'll drag from this socket, release and choose value, and connect this value to the small circle radius. Let's disable this connection for now. Now both circles have a radius of 1, so we add a math node, set it to multiply, and drop it on this connection. Now let's frame these nodes together. Ctrl J, F2, rename it to screw object. We can also add set material node, as we'll need it later. Let's enable this connection and reduce the screw size. Now how to reposition it? We need it to be relative to this stretcher. So let's pin this geometry node, then select this cylinder, then from the outliner, we drag and drop it inside our node's tree. We'll select relative position to use this location and drive our screw position. So we'll first add a point, connect the cylinder location to the point's position input. Then we can add instance on point's node and feed the screw geometry into the instance input. Now we'll cut this connection and replace it with the instance screw. The screw is now right at the origin point of the cylinder. So let's adjust its transformation. Set the Y rotation to -90. Then to change its position, we add transform geometry. And to control the position from the modifier panel, we drag from the translation input socket and choose group input. We still have the stretcher cylinder selected, but we've been editing the pin geometry nodes of the leg. So let's select the leg object to edit its modifier. And here is the translation we've exposed. Let's edit the X value to position it where needed. And we need it before the mirror modifier. But the screw is not mirrored with the leg model. And that's because the screw is an instance, not a real geometry yet. So we need to add realize instances node before joining it to the leg. And here it is mirrored as expected. Next we need to make a boolean around the screw. So we add cylinder. And to position it, we'll use the same point. We'll duplicate this node. Shift Ctrl and D to keep the connections. And we'll replace the screw with the new cylinder. Now to show the cylinder, we'll connect the instance output to the join geometry node. And again to translate it, we'll duplicate this node and use the same translation controls. Now we can adjust its parameters, set the size to 16 and reduce the radius a little bit. Next, instead of joining the cylinder with the leg mesh, we'll add mesh boolean. And here is the screw with the boolean in one modifier, and it's interactive. So if we change the stretcher position, both the screw and boolean will move along. Now let's duplicate the modifier and choose another reference object. But I forgot to add the object to the modifier, so in the object info node, drag from this orange socket and get a group input node. Now we can duplicate the modifier, clear the object, and pick the front apron instead. And we get a new screw automatically. All we need to do is adjust its position. Now let's add some temporary materials. We go to the material properties, Add a material for the leg. Add a new material for the screw. Then in the Set Material node, we pick the screw material. Now let's add more screws. Let's rename this geometry nodes to add screw. It will be easier to identify. To add it to the back leg, we first unpin the front leg geometry nodes, and in the modifiers list, we unpin the subdivision. So when we add the new geometry nodes, it will be created after the subdivision. So we pick the back stretcher, adjust the position, now the side apron. Let's copy this value, pin the mirror, add geometry nodes, pick add screw, pick this object, paste the translation value. Oh, the axes are different. We should use the z-axis. Oops, we have a problem here. Now the screw orientation is wrong, so we need to add another control to set the orientation for each screw. We have two rotations here, so let's try which one will work correctly. Drag from this rotation input and connect it to a group input node and use the same input to control both. No, it's rotating around the point center, I think. So let's try controlling the instance rotation instead. Yeah, that's the right one. But now we lost the rotation we had set when we created the screw. So let's set it back to -90. And this one too. Problem solved. Now let's adjust this position and fix this grid width. Now for the back post, we'll make an extra reference object for each screw. Let's add a plane. Disable it in render. Rename it. And set viewport display to wire. Rotate it. And reposition it. Now select back post. And let's add geometry nodes. Select add screw. I noticed that each time I add this geometry nodes, we get this cylinder object here. To get rid of it, we should delete it from the group settings here. So if we delete this modifier and get a new one, now it's clean. Okay, let's pick the new plane. Adjust the X rotation. We can move the plane closer to the surface. Adjust the translation. And center the plane. Then from the side view, let's duplicate the plane. Select the post. Duplicate our modifier. Pick the new plane. And refine its position. And we're done. Thanks for watching. I hope the video was useful. Please like and subscribe to support the channel. If you have any questions or any improvement suggestions, don't hesitate to drop it in the comments below, and see you soon in the next video.